In the server, we are reading from the TCP stream. This read functionality is defined in the read trait that we import here on the top. And if we look at the documentation for read in the doc.rustlang.org, we get an explanation about what this trait provides, but for all the traits in the standard library, there is a section called implementers, and it lists all the structs from the standard library that implement this trait. And in the implementers for read, we see the TCP stream that we've been using, but here is also a file. There are Unix sockets, and there are references to the above, and also byte slices. That pretty much means that if we wanted to start reading from a file instead of a TCP stream, our code would not change because they both implement the same trait and have the same reading interface. But reading is half the story. There is also a write trait, and if we go to the documentation for write and jump to its implementers, we again see that TCP stream implements write, so we can also write to the stream. We don't only read from it. There is also a file, the standard out is here, and again Unix sockets, vectors, and references. So the read and write traits are at the core of the I/O operations in Rust. And now that we know that TCP stream also implements the write trait, we can go ahead and send the data directly to it. The first thing that we have to do is pull the trait into the scope, so it is also in the I/O module, so we can combine it with the import for read. And the easiest way to write to something that implements the write trait is to use the write macro. We have already used the write macro when we were implementing display traits, and we're using write to the formatter. For example, if you look at the status code, we see that we get past the formatter and we use the write macro to write to it. Okay, but here we actually want to write to the stream. So we specify our stream, and this will be followed by the text that we want to write. Let's hard code some HTTP response for now. So it will go HTTP/1.1, and let's make that a 404 not found, and this has to be followed by 2 new lines. Okay, let's go ahead and test this. If we come to the terminal, we can type cargo run, and this will run our program. It will tell us that the write macro actually returns a result that we are ignoring at the moment, but we'll fix this later. And if we open a browser window and go to 127.0.0.1 at 8080, we see that the browser is telling us that this page cannot be found because it got a 404 response back. If we open the DevTools to the network tab and we refresh, yeah, we see our response, and we see that the server did actually return 404 not found. So we managed to successfully send data back to the client, which is the browser in this case. So now that we know how to write to the stream, it would be great if we can dynamically generate this response from the response struct. The easiest way to do that would be to implement display for the response, and then we can just concatenate it into the string that we're sending down the socket. Okay, so to implement display, we have to import all of the things from the format module, and now we can import display for response. And to implement display, we need the fmt method that takes a reference to self, and it also takes a formatter, which is a mutable reference, and it returns an fmt result. And in here, we again use the write macro, but this time we will write to the formatter. This will be followed by HTTP/1.1. After that, we want to put the status code, and this will be followed by the reason phrase from the status code. Now we need 2 new lines, and this will be followed by the body. Okay, so the first parameter will be self.statuscode. The second will be oops, we need a comma. Okay, we need self.statuscode.reason phrase, and as a third we need the body, but the body is in an option, so we would have to take it out of the option or write an empty string if it was none. So to do that, let's do it up here, and we can say that the variable body will be equal to the result from matching on a reference to the self body. If it is sum containing a body, we just want to return that. Otherwise, if it is none, we want an empty string, and we put a semicolon at the end. So now down here, we can just follow this with the body variable. And we have to remove the semicolon because we are returning the result from the right macro. Now we can go back to the server and create a not found response that we will send. So first we have to actually import the response. So it will be in the HTTP module, and we want to import the response, and we also need the status code. Okay. If we come back here, now we can say, oops, that's on another line. We can say that we want a response new, and in here we have to pass a status code, which would be status code not found. And we also have to pass a body, which is an option. In this case, we want it to be empty. And down here, we can change all of that with just a placeholder, and we can pass the response directly because it implements display. If we go back to the browser now, first we have to recompile our code and run it again, but we should see the same result if we refresh, and yes, we get a 404 again. But I think it would be cooler if we actually return a successful response. So let's change this to OK, and instead of none, we can return some with some HTML. Let's say that we return an H1 with it works. And we have to close this H1 and also call to string on that. And if we go back to the browser again and we rerun it, now when we refresh, we get the HTML back. Isn't that magnificent? We managed to build a working HTTP server from scratch. But let's not get distracted. We can do better. One issue that I have with this implementation is that when we try to send the response to the stream, it will be converted to a string using the FMT implementation that we have. This means that the contents of the response, so these two fields, would be copied to a new string on the heap. And generally, this would be fine. It's not a big issue, but this response contains the body, and this body can be huge. In our case here, it is just a couple of characters of HTML, but a real server might have to serve, let's say, the main.js file for the website, and this file can be 20,000 lines of JavaScript. It doesn't make sense to copy it around in memory because it will be quite large. But we can be smarter and write to the stream without allocating a new string. To achieve this, we'll have to move this write logic to the response itself. So let's go to the response, and in its implementation block, we can create a new public function that we will call send. It will take a reference to self, and it will also take a mutable reference to the TCP stream. And we will have to import the TCP stream. So we can say use std net TCP stream. And we would also need to import the write trait. So from std.io, we would need the write trait, and we would also need the IO result. This result is similar to the FMT result that we get from the FMT module. So let's call this result IO result. And now we can make our send function return an IO result, and it will contain no data. And for the body of our implementation, we want to take the thing that we already implemented for display. Now we can come down here and delete this. The only change that we have to make is to change this f variable to the stream. So now we are using the same macro, but we are writing to the TCP stream directly. Before that, we were writing to the formatter, which would then go ahead and allocate a new string with everything that we wrote to it. But now we are writing directly to the stream and no allocations are needed. And we can go back to the server now. We can delete this write macro and we can just say response.send, and we pass a mutable reference to the TCP stream. Let's test to see if this works. If we rerun it again and we refresh, yep, everything still works fine. Another thing that we can do now is we can send a bad request response every time we fail to parse the incoming request. So when we fail to parse the request, we enter this match arm with the error. So we can actually change this and we can say that we want to create a new response that will have a status code of bad request and it will not have a body. And we can call send directly with a mutable reference to the stream. But now we are sending two responses and both of these methods return a result. So we have to handle this result in these two places. It would be nicer if we don't have to duplicate code to do that. So to make this cleaner, we can assign a result from the match to a variable that we will call response. And down here, after the match, we will just say if we failed to send the response. So we say response.send and we pass a mutable stream. So when we fail, we want to print line failed to send response with the error message that we got. And in here, instead of sending the response, we just have to return it. Same for this case up here, and we remove the variable. So what's happening now is we enter this match expression where we match on the result from parsing the request. If the request was successfully parsed, we build an OK response. Otherwise, we build a bad request response, and one of these responses is assigned to the response variable that we later send to the TCP stream. And our code is much cleaner now.